In this video, we will continue with the 9 infinite series tests for determining convergence divergence for any infinite series. In this video, we will focus on the nth term test, which is also called the divergence test. So yes, let's talk about the nth term test. Nth term test, divergence test for a series. If the limit as if the limit n approaches infinity of the series a of n equals L tangible other than 0, then it diverges. And if the limit as n approaches of the series of a of n equals 0, then we have to choose another test. Okay. So there's only like 3 examples. So let's do example 1. Example 1 says determine if the following series converges or diverges. So we have the series as n approaches 0 to infinity of 4n squared minus n cubed all over 10 plus 2n cubed. So what kind of graph is this? This is a rational function. And how do you find the limit of a rational function? You basically take your horizontal rules, right? You got to find your horizontal. So it's going to be the limit as n approaches infinity of 4n squared So pick the highest term on the numerator. The highest term on the numerator is minus n cubed. The highest term on the bottom is 2n cubed. And what do we know about the degrees? They're the same, right? So the horizontal asymptote is the coefficient. So on the top, the coefficient is a -1, right? This invisible -1, and then on the bottom, it has a coefficient 2. So if it's other than 0, then it diverges. So we could say diverge. Okay, let's look at example 2. We have the summation of n approaches 1 to infinity of e raised to the 2n over n. So we can try plugging in infinity, right? So go ahead and plug in n for infinity. So 2 times infinity is infinity, so it's e to the infinity over infinity. And you get an indeterminate form, you get infinity over infinity. So we have to we want to get a number or other than 0. We'll have to use L'Hopital's rule. So basically, the L'Hopital's rule is you take the derivative of the numerator and then you take the derivative of the denominator. You might have to do it more than once until you get like a real number. So uh, let's do that. So it's going to be the limit as n approaches infinity. And what is the derivative of what is the derivative of e of 2n? Well, that is e to the 2n times the derivative of the power, which the derivative of 2n is 2. So that is going to be 2e to the 2n. And then what's the derivative of n? 1. And then just replace n with infinity. So the 2 times infinity is infinity. So 2 e to infinity over 1. This is still indeterminate, right? You get infinity over 1, which is infinity. So you might have to apply, yeah, no, we can stop here because if you keep on taking the derivative, if you keep it, you can't do the L'Hopital's rule again because if you take the derivative of the bottom, it's 0. So what is infinity? It diverges. Okay, let's do example three. The summation of n equals 4 to infinity. Okay, what kind of graph is this? This is still irrational, so we can just use find the highest term in the pick the highest term on the numerator, the highest term on the bottom. So it's going to be the limit as n approaches infinity. The highest term on the top is, I believe, 5n cubed. The highest term on the bottom is negative 7n4. And what do we know about the degree when the degree on the bottom is bigger than the top? It's bottom heavy. And what is the horizontal asymptote of a bottom heavy? It is 0. So if you go back to the rule, if it's 0, you're going to have to use, if it equals to 0, then we have to choose another test. So you're just going to say choose another test. And we will in the other video. In another video, we will learn about field theories. And we'll stop here.